Good morning, everyone. My name is Azim Karimi, and in this presentation, I'll be examining building approval data from July 2015 to June 2024 using regression analysis. In this video, I'll be explaining how I got my regression models. The first thing I did, this page is for the seasonally adjusted data. So I have my months on column A, and then B column approvals. What I did was I added column C for T for time, and to represent the passage of months, so the regression could measure how approvals change over time. So I made sure that my data was right. Then I went to data over here, and then I went to data analysis. Then I picked regression. I pressed OK, and then for my Y input, I picked approvals, column B. For my X range, I picked column C, the time, and then I picked labels. I picked confidence level, and I put it to 95. And then for the output range, I obviously picked a new sheet to make it more organized and more steady and more look better, And then I pressed OK. Obviously, I'm not going to do that because I already have my data. I'll show you here. Then I have my data here. I made sure that everything is colored nice, and whatever data was necessary, I made sure that I highlighted them to make it a little bit more organized. Then we move on to the second data that we have. Everything's the same. I have my A column, B column, and then C for time again. But here I also have columns D to N for dummy variables to capture seasonal patterns, showing how approvals rise or fall in certain months each year. Again, I made sure that my data was right, and then I went to data analysis. I picked regression, everything the same, Y range the same. For my X range, what I did was it's not only C now, it's C to N. So for my X range, it's from C to N. And then I picked labels. I picked confidence level. I put it to 95. Everything the same on a new sheet to make it more organized and more prepared, make it look better. I pressed OK. I'm not going to do that again because I already have that. I'll show you here. This is the data that I have, and then so everything's nice and clear, everything's highlighted, and then down the bottom here I have the out of sample forecast calculation. So the goal is to identify key patterns and forecast future trends. I developed two models: a linear trend model to measure the overall direction of change, and the second model, which is a seasonal regression model with monthly dummy variables to capture recording seasonal effects. And these two models together help us to explain long-term trends and short-term variations in building approvals. So the first model is a simple linear regression that measures the overall trend in building approvals over time. The regression equation is y equals to 19,546.83 minus 53.85 t, where t is the time. The negative time coefficient, negative 53.85, that indicates a gradual downward trend, meaning that on average monthly building approvals decreased by about 54 units per period. So as you can, if you have a look at the charts I got, figure 1, the fitted line closely follows the actual data, with only small fluctuations around the trend. Forecasts for future months continue this decline, suggesting a steady reduction in building approval activity if the current trend persists. Okay, the second model introduces monthly dummy variables. So that's January to November, to sort of capture seasonal patterns in building approvals. The regression equation here is obviously y equals to 18,345.94 minus 53.48 t, where t is also the time, but plus monthly dummy effect. If you sort of compare this model to the previous model that we looked at, the simple trend model, this approach provides a better fit by accounting for recurring fluctuations across different months. For example, approvals trend to rise during periods such as May and November, but fall during months like January. If you have a look at the charts that I got, figure 2, the fitted line aligns more closely with the actual data, reflecting both the downward trend and the seasonal variation. The forecast for December 2024 and May 2025, that sort of also indicate a continuation of these seasonal patterns. So when comparing the two models, the seasonal regression provides a stronger sort of explanation of variations in building approvals than the simple trend model. Although the linear model captures the overall downward trend, it sort of fails to reflect the month-to-month changes. The seasonal model obviously addresses this by including dummy variables, which we saw on the Excel sheet, resulting in a higher explanatory power and more accurate fitted values. And overall, the seasonal regression model is preferred for forecasting, as it captures both the long-term and the recurring seasonal effects that sort of influence building approvals.